Welcome to another video on A-level integration. Integration is not easy because there are so many different types and different methods. In this video, I'm going to concentrate on where most of the problems occur, in products and quotients. Let's start off by looking at quotients or algebraic fractions. The first question I would ask is it a type 1 integral? Is it f dashed over f? There are two reasons for starting here. One, they're easy to check out, and two, they're quick to solve. Look at this first question. If we differentiate x squared plus 1, we get 2x. We've got 1x. We can make it 2x. And now you can see we have a type 1 integral. Quote the log answer and it's finished. It's quick and easy. A second question. If we differentiate that denominator, we definitely don't get x or a simple multiple of x. It's not a type 1 integral. We'll have to try something else. The second question on my checklist would be, is it what I call a type 2 integral? In a type 2 integral, we have a function inside a bracket. Outside, multiplying the bracket, we have the derivative of that function. So let's take this question. We firstly need to take the bracket to the top line. And then if we differentiate x squared plus 1, we get 2x. We've got 1x. So again, we can make it into a 2x. And now we've got a half of a type 2 integral. Take the bracket, increase the power by 1, divide by the new power. Here's a second question. Is it a type 1? No. Is it a type 2? No. We're going to have to try something else. The third question on my checklist would be, do I need to use partial fractions? And the way we can answer that question is to ask, does the denominator factorize? In our problem, the denominator factorizes to x times x plus 1. So we can split this into partial fractions. Obviously, I've left out the working. We now have two integrals. They're both type 1 integrals. The two log terms can be combined using the second law of logs. And one extra, that constant c, we could rewrite it as c equals log a, and then use the first law of logs to combine the a with the x terms. Now here's a second question. Going through our checklist, is it a type 1? No. Type 2? No. Partial fractions? No. Again, we need something else. If it's none of the first three on our checklist, then it's very likely to be integration by substitution. In this case, we would want to let u equal x plus 1, which we differentiate. We separate the du and the dx, so we've got dx. And then replacing all the x's with the corresponding u terms, we have this. We split that bracket into two parts, each of which we can integrate. And then we replace each of the u's with x plus 1. Sometimes we might need to take it a little further and take, for instance, the power of 0.5 and say that's the square root of the bracket. That's it for integrating quotients. Let's now move on to integrating products. First on my checklist for products would be, is it a type 2 integral? Let's have a look at this question. The first job is to write that square root as a bracket to the power of a half. And then to check whether it's a type 2, look at the inside of the bracket, 5x squared minus 1. Differentiate that and we'd get 10x. We've got 3x. We can arrange for 10x outside the bracket. It is a type 2 integral. take the bracket, increase the power by 1 and divide by the new power. And we're finished. Here's a second question. Is it a type 2? No, we need to look for something else. Next on my checklist for products would be, is it a type 3? A type 3 is where we've got e to the power of a function multiplied by the derivative of that function. Well, the function here is 1 plus cosine x. If we differentiate, we get minus sine x. We can make that into a minus with another minus outside, and then we can quote the answer. Here's a second question. Going through the checklist, is it a type 2? No. Type 3? Certainly not. Again, we need to look for something else. Number 3 on my checklist for products would be, is it integration by parts? We need to be very familiar with the types of problem that are solved by integration by parts. X times cosine, x times sine, these are classic examples for integration by parts. Here we want to differentiate x, so we label that as u. Cosine gets labelled as dv by dx. Applying the formula gives this next line. And our second integral is a straightforward integral of sine 2x. And tidying up, there's our answer. And here's a second question. Is it a type 2 integral? No. Type 3? No. Is it a classic integration by parts question? No. Again, we need something different. You've probably guessed already that number 4 on my checklist for products is going to be substitution. When we make a substitution, we tend to look at the most complicated part and say, let's simplify that bit. Let's simplify it by writing u equals 4 minus x squared. We differentiate, we separate to get dx equals, and then we can rewrite the integral. Sometimes it pays not to change all the x's in the first line of working. Here, if we tidy up those x's, we get an x squared, and we can go back to our let u equals to replace that x squared with 4 minus u. Multiply out the bracket, we have two integrals. And then all that remains to do is replace u with 4 minus x squared and tidy up the constants. Now, if our product is made up of trig functions, something else we might need to do is to convert the trig functions into a different form. We'll have a look at a couple of questions. This first one. Hopefully you'll spot at least one way of doing this problem. The integral of sine x times cosine x. The first method is to recognize it's a half of sine 2x, which we can integrate straight away. But did you also spot that we could convert this into a type 2 integral? We could put the sine x in a bracket to the power of 1. The derivative of sine x is cosine x. It's a type 2 integral. At a first glance, we appear to have two different answers, but they are equivalent. Here's a second example involving trig functions. It's not obvious what to do here, and sometimes we just have to try different things. One option would be to split that cosine to the power of 4, to split it into two parts. And now we can see we've got a tan squared and a sec squared. And then we can put the tan in a bracket to the power of 2 to set it up as a type 2 integral. The derivative of tan is sec squared. So we can take the bracket, increase the power by 1 and divide by the new power. So to summarize what's on my checklist, for quotients, I'd start by asking, is it a type 1? Then, is it a type 2? Is it partial fractions? Could it be integration by substitution? And when it comes to products, I'd start with, is it a type 2, a type 3? Is it integration by parts or substitution? And if there's trig, try converting the trig into a different form. Now, before we finish, I want to mention 4 special integrals. You need to memorize how to do these. Number 1, integrating sine squared and cos squared. You need to rearrange the formulae for cosine 2x, and then you can integrate. Number 2, integrating tan squared. This time you rearrange 1 plus tan squared equals sec squared, and then you can integrate. Number 3, the integral of a to the power of x, where a is a constant. You need to memorize that if y is a to the power of x, then when you differentiate, you get a to the power of x multiplied by log a. So integrating, it's a to the power of x divided by log a. And the last one on my list of specials, how to integrate log x. We write it as 1 times log x, we create a product, and then use integration by parts. That's it for today. I hope you found some of that helpful.